P0300 on this RAM means the PCM is seeing a random or multiple cylinder misfire pattern, not one clean single cylinder story every time. The truck may idle rough, hesitate, lose power, or turn on a flashing MIL during a severe misfire. Stop/start may also be disabled while this code is active. The fault area can be fuel, spark, air flow, oiling and cam control, EGR leakage, carbon buildup, or an engine mechanical problem, so the key is to work the path in order and not guess. Start with the basic system checks first. The misfire monitor is a gate, not the fault itself. Fuel level above 12%, battery voltage above 10, 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F, or if it starts below that threshold, enable once engine temperature reaches 21 degrees C, 69, 8 degrees F. Engine speed is between approximately 400 RPM and 6,200 RPM. The adaptive numerator has to be learned, and the monitor is disabled during a decel fuel shutoff event. The PCM sets this when crankshaft speed variation between cylinders exceeds a calibrated value for the engine speed and load. Turn the ignition on, pull all stored information with the scan tool, and record the codes and captured operating conditions. Then operate the vehicle under the same captured conditions. During the drive, pay attention to when the misfire happens, watch the downstream oxygen sensors while it is happening, and use the misfire monitor to see which cylinders are being counted. If excessive misfires are not happening now, handle it as an intermittent condition. If they are happening now, keep going. A downstream oxygen sensor staying low points you toward a lean condition, like lack of fuel from a plugged injector or fuel system issue. A reading staying high means the catalyst is being loaded with too much fuel, which can happen from lack of spark or a leaking injector. Also remember, on a severe misfire, the PCM may shut off injector control on the affected cylinder to protect the catalyst. That can make a high-load misfire look like it is still there at idle, until the rev counter resets. Before digging deeper into P0300 by itself, look at the other codes you recorded. If there are active or pending faults in the fuel system, ignition components, air handling, VVT or VVL systems, diagnose those first. If there are no related active or pending faults, move into the mechanical and visual inspection path. Now inspect the engine for anything that can disturb crankshaft speed or cylinder contribution. Look for accessory drive issues like a worn belt or misaligned or binding pulleys, improper CKP, CMP, or MAP sensor mounting, poor connector or terminal fitted sensors, throttle body, injectors, coils, and the PCM power and ground circuits. Also check for vacuum leaks, intake or exhaust restriction, internal engine trouble, moisture on ignition parts, insufficient or poor fuel, manual transmission bog, or towing overload. A misfire count does not automatically mean a failed part. Anything that changes crankshaft speed can set this code, and the PCM can shut down injector control for a misfiring cylinder. If you find a problem here, repair it and verify the repair. If this inspection finds nothing, pause, recheck the earlier diagnostic path, and avoid guessing before continuing into the oiling checks. Turn the ignition off and check the oiling side before chasing the usual spark and fuel items. Look for low oil level, aerated oil, an oil filter that does not meet the correct specification, dirty or deteriorated oil, contaminated oil, or incorrect viscosity. The VCT system depends on oil pressure, so oiling problems can make cam timing or valve lift behave erratically and cause a misfire in any operating condition. Next, install the applicable adapter at the oil filter cap and connect an oil pressure gauge. If that adapter is not available, monitor oil pressure with the scan tool. Start the engine, let it idle, and confirm the reading is stable and above 14.0 psi. If oil pressure is below 14 psi or oscillating excessively, cam facer movement can be delayed enough to cause a misfire. Repair the oiling or mechanical condition and verify the repair before moving on. If the oiling checks pass, inspect the intake side. Look over the intake plumbing for restriction, check the air filter for excessive debris, and check the engine for vacuum leaks. If you find a leak or restriction, repair it and verify the repair. If the intake is clean, check the exhaust for physical damage that could cause restriction and excessive backflow. Let the engine idle and check flow at the tailpipe. Repair any exhaust restriction before continuing. Next, check fuel quality. Water in the fuel, wrong fuel type, old or contaminated fuel, and low fuel. Also check for proper ethanol level in the gasoline. If the fuel is bad, replace the fuel and, if necessary, flush and clean the fuel system, then verify the repair. Once fuel quality is handled, the fuel delivery side has to pass before the injector comparison means anything. For the injector check, key on and let fuel pressure reach maximum pressure. Cycling the ignition may be needed. Actuate the injectors for the cylinders showing misfire and watch the fuel pressure gauge. Restore rail pressure. Repeat the same check on 2 or 3 known good cylinders and compare the pressure drops. After each injector actuation, start the engine to clear fuel from the cylinder, because skipping that can damage the engine. If the drop matches the known good injectors, keep going. If the drop is too little, check for debris in the fuel rail or injector and repair as needed. If the drop is too large, suspect a faulty or fouled injector, then verify the repair. Next, check spark on the cylinders that are misfiring. Remove the ignition coil from the suspect cylinder, connect the coil harness connector, disconnect that cylinder's fuel injector connector, install a spark tester on the coil, and crank the engine. You are looking for a good crisp blue spark that can jump the tester gap. A coil or plug problem can show up at idle, but it can also only show under heavy load, and one bad coil or plug will usually point harder at one cylinder. If good spark is not present, go to the ignition circuit checks. If good spark is present, turn the ignition off and inspect the spark plugs. Look for oil or coolant signs in the cylinder, cracks, carbon tracking, oil, coolant or fuel fouling, incorrect gap, or a loose or broken electrode. If the plug has one of those conditions, replace the spark plug, and if oil or coolant is present, diagnose and repair the cause. If the plugs pass inspection, run a compression test on all cylinders and compare known good cylinders to the misfiring cylinders. If compression is not within specification, use a cylinder leak-down test to determine whether the cause is in the valvetrain or combustion chamber, repair as needed, and verify the repair. If compression passes, swap the suspect spark plug with a known good cylinder, or replace the plugs if access makes swapping impractical. Then run the engine and watch the misfire monitor. If the misfire follows the plug or goes away after replacement, replace the spark plugs and verify the repair. If VVT still looks suspicious for the bank where the misfire is happening, follow that bank's camshaft slow response diagnostic path. If spark, plugs, and compression have not identified the fault, check for an EGR valve leaking when it should not. The EGR valve should not flow at idle. If it is stuck open or leaking, it can cause rough idle misfire, and hesitation on initial throttle tip-in, and the misfire should go away or drop off a lot while driving. If there is an EGR tube, let the vehicle cool to ambient temperature, start it, let it idle in park, and watch whether the tube heats quickly from exhaust leaking past the valve. If there is no accessible tube, block EGR flow into the engine by loosening the valve, sliding metal or cardboard between the valve and opening, tightening it enough to seal, and then starting the engine to see whether the rough running or idle misfire is gone. If the EGR valve is the issue, replace it and verify the repair. If EGR is not the issue, clean carbon from the valves and combustion chambers using Mopar combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, test drive under the captured conditions, and watch the misfire monitor. Carbon on valves and guides can cause misfires in all operating conditions, but it is usually more noticeable at cruise or under heavy load, and it can affect more than one cylinder. If the misfire does not return after cleaning, the cleaning repaired the fault and you still verify the repair. If the misfire returns, Continue to the coil driver circuit checks. If the earlier spark check showed no spark, start at the ASD relay output circuit. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay output at the coil connector. If the test light does not illuminate brightly, repair the open or short to ground between the PDC and the ignition coil connector. Stop all actuations and verify the repair. If it does illuminate brightly, move to coil control operation. Stay clear of the fan, pulleys, belts, and loose clothing anytime the engine is operating. For the coil control check, use a 12-volt test light connected to a 12-volt source. Probe the coil control circuit at the coil connector and crank the engine for 5.0 seconds. If the light blinks brightly, replace the ignition coil and verify the repair. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect the PCM-C2 connector, install the GPEC Diagnostic 10436 adapter, and check continuity between ground and the coil control circuit at the coil connector. Do not probe the PCM harness connectors. That can damage the terminals and create a poor terminal-to-pin connection. If there is continuity to ground, repair the short to ground and verify the repair. If there is no continuity, move to the connector inspection path. If the light stays OFF constantly during the coil control check, test the coil control circuit for an open. With the PCM-C2 connector disconnected and the adapter installed, measure resistance between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, move to connector inspection. If it is not below 3.0 ohms, repair the open or high resistance in the coil control circuit and verify the repair. At the end of the path, inspect the related PCM inline and component connections. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Check connector installation, locks, corrosion, water intrusion, weather seals, bent terminals, overheated terminals, push-back terminals, spread terminals, and terminal tension. Repair anything you find. Then reconnect every connector fully and make sure the locks are engaged. Erase the codes. Operate the vehicle under the monitor and set conditions and read codes again. If P0300 returns after all of these checks, replace the PCM and verify the repair. If it does not return, verify the repair and confirm the code stays gone. The takeaway is simple. With P0300, prove the operating condition. Identify which cylinders are counting, rule out oiling, air, exhaust, fuel, spark, mechanical, Egger, carbon, and coil control in order, and only make the final call after the verification drive. For more diagnostic training, visit stepdiagnostics.com.